Hello everyone, so in today's video I would like to describe in a bit more detail some of the optimization features that are in Rolling Line, and specifically like how it loads maps. And this latest update that's just coming out now is all about reducing RAM usage for map loading and basically optimizing the process of loading very big maps, and basically just making some changes to how track is loaded and how meshes are managed, which has a huge benefit on performance. In some cases looking at 50% reductions in RAM usage and like 20-30 seconds faster loading time on some big maps. I'll give you some examples here of how this works, and I'll show you what the new loading process is like. So here is an example of loading up a map, and I'll show how the chunk loading and level of detail stuff works. So as you can probably expect, using the Nevada, Arizona and Utah map, which if anyone remembers was a really famous map back in the day, just because it's really big and it has track covering a lot of space. So it's always been a good one for testing anything to do with loading maps or loading large areas. But firstly, if I pause this, the loading screen goes through a bunch of different steps as things happen, and I'll try and explain a few of them. This initial one, loading room objects, this is loading the tables and the switchboards, things like that, controllers, regions, any sort of like data stuff and room stuff, because anything that's dependent on from other objects. So something like a switchboard is dependent on track, so you have to load it in first. You can't sort of, load it in along with all the rest of the props. But I'll resume this. Next one is preloading track. For this recent update, which is what this is coming up next, what this video is about, I've actually really optimized how this works. So in the past, the preloading track would actually have to load all the track in the map, including its meshes, its materials, all that data. Basically all the data related to track was loaded in from the beginning, no matter how big the map was. And that causes big trouble when you have, these massive maps with 10,000 track objects, and it meant that even just starting those maps could take minutes of loading time. But after this update, I've now made it that the preloading track stage is only loading in the bare minimum amount of information, which in this case is like the waypoint data of how the trains actually interact with the track, and it doesn't load any visual stuff. So it loads no meshes, no materials, nothing like that. So it's significantly faster. You'll notice this preloading track stage zips through at about 5 or 6 times faster than it used to, and it will now load those meshes at a separate loading stage. In fact, if I pause this, we can actually start to see, if we go over to this is a bit of a developer scene view, you can actually start to see how the room, the tables, has been loaded in. You can start to see these showing up, and soon, once it's loaded all of the track, it'll actually start loading in the chunks. Okay, so this next step, loading chunks, this is where it actually starts to load in track and props. And let's see, it'll take a wee while for a few of these to show up, so I'll let it load a few more. You'll see that it's picked 169 chunks here. When the game starts loading the map, it will basically choose all the chunks that are near the player, near where the player is going to spawn. So that's why it says preloading chunks, because it is loading everything that you're going to see when the map first starts, and everything outside of this is loaded just asynchronously in real time once you're actually playing the map. So it basically only loads what it needs to, and you'll see it's loading in track, it's loading in props, everything. So this is everything you're going to see. There we go. And now that we are in the map again, yeah, you can see it's loaded just the area around the player, and depending on your graphic settings, that will be either larger or smaller. Obviously, if you set the graphic settings to infinite, it will just load the entire map, which pretty much circumvents any optimizations that are in there. So this is on, I believe, far at the moment, this render setting. But as you move around, it will start to load in new chunks. And if I teleport quite quickly, you can see this happening. So if I teleport over here, you'll suddenly see everything start to load in. All the track, all the props, all that. And now that all that new stuff being loaded in is now loaded into RAM, and it will start to use up more RAM. And with the way the game works, at least for now, it keeps this data in RAM. So basically this means I've loaded this area, I've also loaded the original area where I was before, which means if I go back over there, it will load instantly. There won't be any like loading process as it reloads this because it already keeps it. So you can just basically move around these areas without any lag. And as you load through a map, you load more and more of it, which is actually why the much larger maps actually can result in crashes from running out of memory because, well, you've loaded so much of the map that's used up all of your computer's memory. And those larger maps are always a big problem, and I'm working on ways to optimize that. But at least for this update, the main thing it's doing is making it so that all this track mesh data that you see is being loaded in basically asynchronously as you move around, instead of it all being loaded at the beginning. And there's a lot of other stuff happening under the hood. It's not just related to track. There was all sorts of optimizations relating to how meshes are stored in RAM, and some other stuff like just basically how it keeps copies of meshes when it needs them, lots of little things like that, but that's getting quite into the nitty gritty. Yeah, so that's basically all I can show on this map. I can show a few other examples as well. So for another example, here is the national park map where there's a lot of dense scenery, so it's quite visually obvious which areas are being loaded and which aren't. So if I start loading this one, you'll see it does the preloading track stage, which is now super fast. That was like a couple of seconds. And now that's doing loading chunks, I'll pause it about here. We can sort of start to see some chunks being loaded down here. So the player is going to spawn in next to the Raurimu spiral, so it's only loading chunks around that area. But I'll let it cycle through a few more so it's a bit more obvious. There we go. Yeah, so now you can really see that the chunks are starting to show up down this area. And it's really efficient because if it's only loading in props here, it's essentially ignoring the entire rest of the map, which is, you know, hundreds of thousands of props. Those are just stored in save file data for now. So no objects are spawned in, those props aren't even loaded into memory if they don't need to be. As the player moves around, it will actually start splitting that save file data further and loading the props over there as it needs them. So that's why you'll notice that it can be quite quick now to load these very large maps from the start. But obviously that loading is now spread out more as you move through the map. And there are still optimization issues there where when maps are very large, that RAM builds up over time, as explained. So one option for that is to actually find a way of removing old chunks out of the map, but then that has the trade-off of if you start going back the way you came, you've got to reload it all again. So I'm looking at options for that, of trying to find a balance where it'll only start to unload those sections of the map if it absolutely has to, like if your RAM is being almost completely used up, because it should only really affect some of the largest maps. In most cases you can happily load up an entire map like this without consuming too much RAM at all, which is great because then you can just walk around the whole map without creating any lag, which is far nicer than having to reload everything as you move around. But if I let this continue, yeah, and it will spawn us in over by the Raurimu spiral, and as you can see, all of this stuff is nicely loaded in, but none of this is yet. And if I were to teleport all the way over there, yeah, you would see all this start to load in, and you can see the frame rate is still a bit shaky as it loads, and then once everything is finished, it will go a lot smoother. Yeah, and now it's smoothed right out, now that's loaded everything. For a bit more of a sort of technical dive on this, here are actually some memory statistics comparing a older copy of the game from just before this latest update, which is on the right hand side here, and on the left hand side here is after all of these new RAM optimizations. So on the left hand side, the main thing you'll definitely notice is that meshes are using up the vast majority of RAM. The amount of RAM used up by textures has also improved a bit, but in general, everything else has stayed relatively the same. The bulk of this update's optimization has all been around mesh usage. So this comparison was actually from loading the Beaumont map, which is another massive, famous, really big one that uses a lot of track, a ridiculous amount of track. I think something about 8,000 track pieces. So without this update, it was using 2.9 gigs, well, actually no, 4.5 gigs worth of RAM purely on meshes, and that's on one initial load, normal render distance. This is just starting the map. And compare that to now, where it is using only 0.9 gigabytes, less than 1 gigabyte on meshes. And that is because it is loading in basically only the track it needs to, instead of having to load everything, because the track is really demanding when you have so much of it in a map. And there was also a lot of optimizations I did around accidental or just unnecessary duplication of mesh data. So in the Unity game engine, there's a lot of ways that you can basically create duplicates of mesh data. And it can be quite tricky to actually find some of them, especially in a game like this, which involves dynamically changing meshes a lot of the time. Things like the way track is generated, it's actually a deformed mesh, where as the game runs, it will actually generate those pieces of track as it needs them. So I dug into that quite a bit and had a look at where those duplications were happening, and the changes are massive. Like you'll see here, 36,000 objects of mesh. That is reduced from 195,000 objects of mesh. That is a massive difference. But yeah, these optimizations are really good for large maps. Even for small maps, you'll notice quite significant improvements. Just loading screens in general are significantly improved across the board, and most of all, RAM usage. Like in this example here, it's almost a 50% reduction in RAM usage for loading this map, which is quite exciting, and it's great testing this on other big maps and just seeing how well it works. So with something like this, you can basically run a gigantic map like Beaumont for like under 4 gigabytes or under 5 gigabytes of RAM, which is pretty good. That's about what I would hope for. I don't think I can get it too much crazier than that. There's obviously still more room for optimization, but I think that's a pretty fair amount of RAM usage for such a massive map. And of course, all the normal maps, all the smaller ones, or the official ones, run in usually about 3 gigabytes or even less, down to 2 gigabytes on some of them, which is great. I mean, that's the sort of RAM usage you could even get out of laptops, not even needing a desktop PC for something like that, which is quite nice. I'm glad that Rolling Line is able to perform on hardware like that. It's good to not need 16 gigabytes of RAM to be able to run your most basic maps. But yeah, that's just a bit of a deep dive on some of the details as to what's actually going on in this new update and what this RAM reduction is all about. So thank you for listening. I hope this was an interesting video, definitely a bit more technical than just doing like a layout tour, but I'm sure there's people out there that would love to hear this sort of stuff and learn more about the detailed aspects of how this game is made. So yeah, thank you for listening.